Taking a look at our geometry section, we have an example that starts off talking about how geometry is useful in problem solving. So we are given a problem that deals with a tree, and the problem is that we want to know the measure of the tree, but we do not have a way to directly measure it. So what we're going to do is use something called indirect measurement, where we compare the height and the shadow of a tree to the height and the shadow of an object very close in location to the tree. And we'll talk about at the end of this problem why that works. So we start off with a tree casting a shadow of 15 feet long. And then I'm going to compare the shadow of that tree to myself. And I'm going to have a friend help me measure my height and my shadow. So suppose I am 6 feet tall and I cast a 1.5 foot shadow. So here I am, not drawn to scale, obviously. And there's my shadow, 1.5 feet, and my height of 6 feet. And the reason this indirect measurement works is because we have the elevation to the sun that's creating an angle that hits the tree and it hits myself at the same angle. And we can use similar triangles to make this work. So we have the sun. I'm going to put it over to the left because of the way that the shadows are. Oops, sorry. And we have the sun hitting the tree and casting that shadow. And if I was standing close enough to the tree in my picture, it would hit me at the same angle. And the sunbeams would then cast a shadow to the right as I have drawn in my picture. So using this, what I can do now is I can set up a proportion with these triangles of the height of the tree compared to its shadow, and it should be proportional to my height compared to my shadow. So my proportion, height over 15 feet equals 6 feet over 1.5 feet. And then all I have to do is use those methods we have for solving proportions, mainly multiplying the denominator on the left times the numerator on the right. So 15 feet times 6 feet gives me 90. And I'm going to go ahead and write feet squared because we're multiplying feet times feet. And we'll take care of that when we do our division in a minute. And then I'm going to multiply the numerator on the left times the denominator on the right. And then the only thing left now is to get the height by itself, which means I divide by 1.5 feet. And this is where that square up there cancels with the feet in the denominator. And we're just left with feet on the left-hand side of our equation. So 90 divided by 1.5 gives us 60 feet. So the tree is 60 feet tall. And once again, this is an example of using geometry to help us solve a problem that we could not measure directly.